okay? So we're not using a set definition, we're using a logical definition, okay? So we can just say, thus x is an element of B and x is an element of A by Boolean law of logic, or Boolean law commutative. Okay. Or you just say commutative law, whatever you want to do. Just make sure you say like the Boolean law of that. Okay. So is that okay with everybody, guys? Nobody doubts that. Well, since now we have x is an element of B and x is an element of A, couldn't we say that x is an element of what?
A and B.
Not A and B, but
B and A.
B and A, right? Because we just, you already know that it's x is an element of B, A and B, but x is an element now of B and A. Now, what allows me to say that, though?
That's the associative law.
Not associative. Good try. We didn't move any parentheses around. Procedural definition, right? We're just going backwards from the procedural, okay? So let's look at the top, guys. This time we have x is an element of B and x is an element of A. We're just going backwards this time, aren't we, guys? And we're just saying, now we're going from right-hand side to left-hand side. Okay, nice job. So, thus, x is an element of B and A by the procedural definition. And we're done with case one. Because now that we've shown that for all x in A and B, x is also an element of B and A. Okay, or B intersect A. So we've done it. And like I said, it is extremely low level. Okay, so some of you guys are probably thinking like really high level of algebra stuff that we've been doing. Try to think low level with this stuff. Okay, it's almost like assembly programming. How many of you guys have suffered through assembly or are suffering? How low level is that stuff, guys? Like you have to find every single register that you utilize, right? It's extremely tedious sometimes, okay? So this is one of the reasons I do this, is just for those of you guys that are going through assembly, to try to make some of the connections with how low level it is. Okay, so we need a case two. So for case two, are we trying to show that B intersect A is a subset of A intersect B? How do you guys think we do that? Exactly like we just did the other one, except we just reverse all the A's and B's, okay? Usually, when you do this sort of thing with the axiomatic definitions, they're all the same. Once you get the first case down, usually the second case is about the same, okay? So let's just go ahead and write it out, okay? Not meant to be too difficult, okay? So we're going to let x be an element of B intersect A by the procedural definition, or axiomatic, whichever one you want to say. So by procedural definition, x is an element of B, and x is an element of A. We just used the Boolean law of logic, or the commutative law of Boolean algebra. Okay? So thus, x is an element of A, and x is an element of B by commutative law of Boolean logic. And then finally, we can just use the procedural definition once again and say, thus, x is an element of A intersect B by our procedural definition. Okay. So, very, very low level stuff, okay? But that's how we have to prove these sets, these initial set, I guess theorems what we're working with, okay? So, sort of like when we prove things with the truth tables initially with Boolean logic, we're doing the same thing here, which is basically using the Boolean logic to prove that. So it's almost like an evolution of what we're doing. Alright, so guys, this proof would get us 9 out of 10 points. What's the only other thing we'd have to do to get all 10?
That's by case 1 and case
Yeah,
2.
case 1, case 2, the result is true. Okay, so therefore, by case 1 and case 2, A intersect B is indeed equal to B intersect A. Okay, we already knew that, okay, but now we finally got to prove that's true. So, let me give you guys a moment to copy all that down, and then a chance to ask me some questions that you guys might have. Anything I can answer, guys, involving this one? Okay, like I said, pretty low level stuff, and when I say low level, I don't mean it's easy, you just have to dumb yourself down, okay? Well, Donnie, that's not a problem, is it? Sorry, I had to say it. So. Boy, you're just so tired you don't even want to insult me back. Jeez. Oh, you're lame. All right. A more difficult proof, okay? This is the absorption law, okay? So I want to prove that if I have sets A and B, that if I have A intersect A union B, that's equal to A, okay? Now this is an example of a proof to where case 1 and case 2 are not the same. Okay, one of the cases is extremely easy. The other case, you kind of have to pull something out of the blue. Okay, so I'm going to show you guys what I mean by this. Okay, so just like we did before, let's let A and B be any sets. So let's let A and B be sets. And let's let X be an element in the universe. Say arbitrary or particular if we choose to. So arbitrary but Case 1 is extremely easy. Okay, case 2 involves a lot of foresight. Okay, so let's do the easy case first. Case 1, what I'm trying to show is that A intersect A union B is an element, or is a subset, sorry, of A. So, all we have to do, we're just going to let X be an element of A intersect A union B. That's easy enough. That's how we always start these types of proofs. We just say, let's let X be an element of the right hand or the left hand side. What do you guys think might be a good next step to be able to try to go forth with this? Well, what's the only thing we know how to do with sets?
Can you like separate them like A and A, then B, like what is that called? That forgot the name. Like,
Are you talking about like a distributive property?
yeah, distributed.
Well, we don't know that yet, though. We can't prove that. Okay.
Oh, it's not just say that means X is an element of A and
Yes.
X is an element of A union B.
Use the procedural definitions. Correct. Okay. Or were you talking about like saying A and A or A and B? We can't do that yet. We haven't proven that. Okay. If we did prove that, then yeah, we could. Okay. So, but James, I like your idea. Let's use the procedural definitions. Guys, first thing you do is you say X is an element on the left side, then you always use your procedural definitions. It's the only way we can go with this. Okay, so by procedural definition, we can say that this means that X is an element of A and X is an element of A or
B.
X is an element of B. Okay, and I'm going to put this in parentheses. Okay. All right. Now let's think about this. I think we're done with this, because I've told you that X is an element of A, and X is an element of A or B, right? Well, what do we want, guys? What are we ultimately trying to show? X is an element of A. I'm telling you that X is an element of A, and X is an element of B, okay? I have blue marker and black marker. I have blue marker and black marker, right? Which one do I usually write with? Black marker, so I pick black marker. With an AND statement, I can pick either one of these that I want. I'm just going to pick A. That's the definition of an intersection between, okay? Or the definition of a conjunction, okay? So we could say thus, now this only works for an AND. So thus, X is an element of A, okay? And we could say that's the definition of a conjunction. So with an AND, like I said, it only works for ANDs. If you have OR, you can't do that, okay? Because on your homework, you're going to have an OR, and some of you guys are going to try to do that with an OR, and you can't do that, okay? So, does that make sense to everybody, guys? If you have two things, if you have one thing and another thing, you can pick whichever one you want, okay? It doesn't matter which one, okay? Well, guys, we're done, okay? We've already shown that X is now an element of A, and we have our subset done. So if X is an element of this, then X is definitely an element of X is an element of A. Okay? Does that make sense, guys? Any questions about that? Okay? All right, so let's do the other one. The other one's a lot tougher. You have to be sneaky with this one. Okay, so case 2. Now this is why it's tough. We are trying to show that A is a subset of A and A or B, right, guys? And this is why this one's so tricky, okay? What's the first line that you guys are going to write in this proof, or for this case 2? Let X be an element of A. You always start by letting X be an element of the left-hand side. Why is that tough to do anything with? There's no definitions. There's no set operations. There's no procedural definitions. I mean, that's just saying, let's start out with the number 1. Not even 1 plus 1. Because if I gave you 1 plus 1, you'd know what to do. But if I just put a 1 on the board and said to do that, you guys would have no idea because there's no operator there. Okay? We are ultimately trying to show that X is an element of A and A union B, right? Now, we've already got the left-hand side. Everybody would agree with that, right? I already know X is an element of A. So all I have to do is somehow show that X is an element of A or B, right? So, let's play this game again. I always like to play the logic game, okay? In my hand, I have black marker or rattlesnake that's going to bite Paul in the face, okay? Which one do I have? Black marker, right? Thank God I don't have the rattlesnake, otherwise you'd be really pissed off at me, okay? Or you'd be running, and then be pissed off at me. In my hand, I have black marker or $3 million. In my hand, I have black marker or cure to cancer. In my hand, I have black marker and Art's hairs, okay? Wherever they went. I don't know how long it's been since you've been bald. Too long?
Too long,
Okay.
yeah.
What's the point that I'm saying, guys? As long as one of these is true, I can say or anything else, right? So, thus, X is an element of A, or X is an element of any other set I want it to be. Either life-threatening cobra, or it's lost follicles, whatever you might want to say. What do we want X to be an element in for this problem?
A or
B, right? We want X to be an element of B, okay? And I'm going to make a note that it could be an element of whatever set that we want it to be. We just pick B because that'll get us to A or B. Does that make sense to everybody, guys? If it's an or, you can pick whatever you want because that's not a lie, as long as the first part is true. And guys, this is true. We let X be an element of A. You have to suppose that that's true.
Oh, that's the generalization, specialization.
That's going to be generalization.
Yeah,
Okay?
okay,
It's
got it.
actually the definition of a disjunction. if you will, Okay? So it could be any set, and I'm going to write this here. This could be any set that we want it to be, okay? As long as it's or. Can't do that with and, okay? You cannot build X is an element of A and X is an element of B, okay? So, guys, do we see these subtle definitions between ands and ors, okay? If you have and, you can pick either one you want. You can build an or, okay, but you can't build an and, okay? So try to keep that in mind when you guys are working with your homework, okay? Well, guys, now can we just use the procedural definition, okay? So, oh, by the way, we need a justification for this. So does X is an element of A or B, okay? That's the definition of a disjunction. Okay, remember disjunction means or, conjunction means and. And then we can go ahead and we can just say, well, this is going to be our procedural definition. So by procedural definition, X is an element of A union B. And guys, isn't it clear that X is an element of A, and also at the same time, X is an element of A or B? We've got both sides of this. We have X is an A and X is an A or B. Okay, so we're basically done with this. Okay, so thus, X is an element of A, and X is an element of A or B, as shown above. Okay, I mean, it's clear that we have both of those. Okay. And by procedural definition, we can just stick a union or an intersection in for the and. Okay, so, and one more time, by procedural definition, X is an element of A intersect